Section 10.5, the distance formula. Essential question. How do you find the distance between any 2 points? So when we're talking about 2 points, we are referring to 2 coordinate points on a coordinate grid. So either you can look at a line or look at a graph and take 2 ordered pairs on the line and find the distance between them, or you're just given the ordered pairs without a graph and you find the distance between them. So you're just finding out how far away are 2 ordered pairs from each other. So the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, find the distance between the 2 coordinates, 5, 3, and 1, negative 2. So the first thing we're going to do on every problem is label the ordered pairs. So it always goes x1, y1, and then x2, y2. And then we're just going to plug stuff into that big, long, red formula on top. All right, so x2 is 1 minus x1, which is 5, squared, plus y2 is negative 2 minus y1, which is 3 squared. All right, then my next step in PEMDAS would be parentheses. So 1 minus 5 is negative 4, and negative 2 minus 3 is negative 5. Don't forget that both parentheses get squared. Then we're going to take our next step and actually do the squaring. So remember that a negative number squared is always a positive. So the numbers that end up under your square root should always be positive. Keep in mind, distance can't be negative. So we can't end up with any negative numbers after we square. All right, so then D equals the square root of 16 plus 25. And if I add together 16 plus 25, I get 41. And then don't forget to take the square root of that. So square root of 41 is 6.4. So the distance between those 2 ordered pairs is 6.4. All right, now we're going to find the distance between 4, 2 and negative 3, negative 1. So I'll start once again by labeling x1, y1, x2, y2. D equals the square root of x2, so negative 3 minus x1, 4, squared, plus y2, negative 1 minus y1, 2, and then square that. All right, so then I'll do my parentheses, simplify those. So negative 3 minus 4 is negative 7. Negative 1 minus 2 is negative 3. Then I will square both of those numbers. So this is where we're only going to end up with positives. Negative 7 squared, negative 7 times negative 7 is positive 49. Negative 3 squared, so negative 3 times negative 3 is positive 9. After I add up 49 and 9, I end up with D equals the square root of 57. If I take my calculator and do the square root of 57, I end up with 7.5. So the distance between these 2 ordered pairs is 7.5. All right, negative 7, negative 2, and negative 5, negative 8. x1, y1, x2, y2. D equals the square root of x2, so negative 5, minus x1. Now this one is minus a negative, so we're going to have a chunky plus. So anytime we're subtracting a negative, it ends up being a chunky plus. So plus y2, negative 8, minus y1, so minus a negative 2. So we'll have 2 chunky pluses on this problem. All right, simplify my parentheses. So negative 5 plus 7 is 2. Negative 8 plus 2 is negative 6. 2 squared is 4. Negative 6 squared is positive 36. 4 plus 36 is 40. And the square root of 40 is 6.3. So the distance between these two ordered pairs is 6.3. Find the distance between the two coordinate points. So now we have a graph. We are going to write the ordered pairs down for both of these points. So we have -1, -2. And we have 3, -4. So I'm going to write both of those ordered pairs down at the top here. -1, -2, and 3, -4. So I'm going to do the same process now as I did in the last problem. So label my ordered pairs, x1, y1, x2, y2. D equals the square root of x2, so 3 minus x1, so minus a -1, chunky plus y2, so -4, minus y1, so minus a -2, so another chunky plus. Simplify my parentheses. 3 plus 1 is 4. -4 plus 2 is -2.
Mrs. Demmer, please call extension 6801. Mrs. Demmer, 6801.
So 4 squared is 16. -2 squared is 4. 16 plus 4 is 20. And the square root of 20 is 4.5. So the distance between these two ordered pairs is 4.5. Summary.